In this lesson, we are going to look at linear quadratic systems. So we are going to solve linear quadratic systems in two variables algebraically. So linear quadratic systems means that you are going to have one equation that's linear, so a straight line, and then one equation or function that is a quadratic. So a quadratic is your parabola, that U shape. But looking at it as an equation, its highest power for your variable is going to be squared. So linear, you have just x. Quadratics, you have x squared. So in example 1, we are going to look at graphs and determine the number of solutions. So we're just going to state the number of real solutions based on what we are observing. So for A, I have my two graphs there. I have my parabola and my linear equation. They intersect twice here. Okay, so since they intersect twice, that means you are going to have two real solutions. So they intersect twice. That means they're crossing. And since they're intersecting twice, you have two real solutions. For B, my graphs do not cross at all. They do not intersect. So in this case, there are no real solutions. There's a possibility that there are some imaginary solutions, but we can't observe that off a graph. We would actually have to algebraically go solve for that. And then for C, my two graphs intersect once. So that means I am going to have one real solution. So if they intersect twice, that's two real solutions. They don't intersect at all, no real solutions. And then if they only intersect once, and that should say once, not one, that means there's going to be one real solution. So for example 2, and the main focus of this lesson is going to be solve a linear quadratic system using substitution. Previously, we looked at substitution when we had two linear equations. Today, we're going to have one that's a quadratic and one that's linear. Again, quadratic has a power of 2, exponent of 2, and linear only an exponent of 1. So we're going to have 6 steps here. Step 1 is going to be to substitute. Step 2, set it equal to 0. Step 3, factor. Step 4, set your factors equal to 0 and solve. Step 5, we're going to solve for the remaining variable. So in step 4, you're either solving for x or y, and then step 5, you have to solve for the opposite. And then step 6, you're writing your answers, your solutions, as an ordered pair. So first step, I'm going to go substitute. Now, both my equations are solved for y. You always want to have one of your equations solved for x or y, so you can take that value, substitute it into your second equation. So I'm going to take what y equals in my first equation, negative 2x squared plus 24, and I'm going to substitute it in for y in my second equation. So essentially, I'm just bringing it on over. So now my second equation, that y is becoming negative 2x squared plus 24x, and it equals 2x. Now, step 2, I need to set it equal to 0. So I need to get everything to one side. So I'm going to go ahead and move everything to the left-hand side. So I'm going to move that 2x by subtracting 2x from both sides. So now I simplify. So I'm going to have negative 2x squared plus 24x minus 2x gives me 22x equals 0. So step 2, get everything to one side, set it equal to 0. So now step 3, I need to go factor. Whenever I factor, I always want to check for a GCF first. So here in my equation, I have negative 2 and 22. I can pull out a negative 2 as a GCF. And then x squared and x, I can pull out x. So my GCF is going to be negative 2x. So now I'm going to write what's left inside my parentheses. So I take my first term, negative 2x squared, divide that by negative 2x. I get just x. And then 22x divided by negative 2x, a positive divided by negative is a negative. And then 22 divided by 2 is 11. X divided by x is just 1. So I'm just left with negative 11. And this still equals 0. So my factored form is negative 2x times the quantity x minus 11 equals 0. Step 4, set my factors equal to 0 and solve. So my first factor is negative 2x. I'm going to set that equal to 0. Second factor, x minus 11, set that equal to 0. I'm going to go solve both my equations. So for first equation, I'm going to go ahead and divide both sides by negative 2. So I get x equals 0 divided by negative 2 is 0. So first x value is going to be 0. Second equation, add 11 to both sides. So I get x equals 11. So this is not my solution yet. I need to write these answers as ordered pairs. So I need the x and the y value. So for step 5, I'm going to solve for the remaining variable. So I'm going to take my x values. So I have x equals 0 and x equals 11. I'm going to pick, excuse me, one of my original equations to substitute in x and solve for y. I'm going to use my second equation just because it's a little bit simpler to simplify. So I'm going to use y equals 2x. So I'm going to go ahead and substitute in what we got for x. I have to do this twice. So first equation, I'm going to have y equals 2 times 0. And 2 times 0 equals 0. Second equation, substituting in 11. So I'm going to have 2 times 11. And 2 times 11 equals 22. In step 6, I'm going to write my solutions as an ordered pair. So I'm going to have two solutions, so two ordered pairs. So my first ordered pair was x equals 0 and y equals 0. So I'm going to have 0, comma 0 as my first solution. Second solution, I had x equals 11 and y equals 22. So my solution, or my ordered pair, will be 11, comma 22. So my two solutions, 0, 0 and 11, 22. So now we're going to go ahead and look at example B. For example B, I have y equals 3x squared plus 3x minus 5 and 2x minus y equals 3. Now, only one equation has y by itself, that first equation. So I'm going to substitute that into my second equation for y. So second equation is now going to become 2x minus, and then in parentheses I'm substituting in 3x squared plus 3x minus 5, and this equals 3. Now I'm going to distribute that negative on the outside first, so I can get to the process of setting it equal to 0. So I'm going to have 2x. I'm going to distribute that negative to 3x squared. So negative 3x squared. Distribute it to the 3x. So minus 3x. Negative times negative 5 will give me a positive 5. And then this equals 3. Now to get it all to one side, I need to move that 3 on the right over to the left. So I'm going to subtract 3 from both sides. And while I'm doing this, I'm going to look at like terms as well. My like terms here are 2x and negative 3x. So I'm going to write my negative 3x squared first. And then the 2x minus 3x gives me negative x. And then when I'm simplifying with that 3, 5 minus 3 gives me 2. So plus 2 equals right-hand side, 3 minus 3 gives me 0. So again, in this step, I went and combined my like terms. So the 2x minus 3x gave me this negative x. 2 minus 3 is negative 1. And then the 5 minus 3 gave me 2. So when I have everything on one side, I have negative 3x squared minus x plus 2 equals 0. Now I need to go ahead and factor. When I go to factor, I check for a GCF, no GCF. I also want to make sure my x squared term is positive. So I'm going to pull out a -1 to make my x squared positive. So that means I just changed the signs of everything. So -3x squared becomes positive 3x squared, negative x becomes positive x, positive 2 becomes -2. Now this makes it a little bit easier to go ahead and factor. So to factor this, I need to look at factors of 3, factors of 2, outer plus inner equals 1. So factors of 3, factors of 2, outer plus inner equals 1. So I'm going to go ahead and set up my parentheses so those are ready to go. Now my factors of 2, my C is negative, so my factors of 2, one will be positive, one will be negative. So factors of 3 are 1 and 3, factors of 2 are 1 and 2. So I'm going to do 1 times -2. Now I do my outer, 1 times -2 will give me -2, plus my inner, 3 times 1 will give me 3, and then -2 plus 3 gives me 1. So now that's what I wanted for my outer plus inner, so I'm going to go write my expressions. Factors of 3 will be the coefficient of x, so I have 1x and 3x. Factors of 2 become the number piece of my factor, so I have +1 and -2. Now step 4, set your factors equal to 0 and solve. So my first factor is x plus 1, set it equal to 0. Second factor, 3x minus 2 equals 0. From here, I'm going to get my x by itself. So I'm going to subtract 1 from both sides. So I get x equals -1. Second equation, I need to add 2 to both sides to get 3x by itself. So I have 3x equals 2. Then divide both sides by 3. So I get x equals 2 over 3. So now step 5, I'm going to go solve for my remaining variable. So I'm going to use my x values, so -1 and 2/3. And I need to pick one of my original equations to substitute those values in and solve for y. So you can either use the first or the second, doesn't matter which one. I'm going to choose to use the second equation. So 2x minus y equals 3. And again, you can choose the first equation, you should get the same answers. So I'm going to go ahead and substitute in x. So I'm going to have 2 times -1 minus y equals 3. 2 times -1 is -2. Minus y equals 3. I'm going to add 2 to both sides to get y by itself. Remember, this is a negative y, so I have -y equals 5. Then to get the positive value, I'm going to divide both sides by -1. So I get y equals -5. So my first ordered pair for my solution will be -1, -5. Now I need to repeat that process for my second x value. So I'm going to go ahead and substitute in 2/3. So I'm going to have 2 times 2/3 minus y equals 3. 2 times 2/3 is 4/3 minus y equals 3. Now I need to get y by itself. So I'm going to subtract 4/3 from both sides. So I get -y equals, and now I need to do 3 minus 4/3. So whenever you subtract with fractions, it's easier to rewrite your numbers so you can easily subtract. So I'm going to rewrite 3 as 2 and 3/3. 3/3 is just 1, so I still have the value of 3. And 4/3 is actually the mixed number 1 and 1/3. So when I subtract down 3/3 minus 1/3 gives me 2/3. And 2 minus 1 gives me 1. So you can either leave this as a mixed number or write it as an improper fraction. You go around the world. 3 times 1 is 3, plus 2 is 5. Keep your denominator. So you can either write 1 and 2/3 or 5 over 3. Now to get positive y, I need to divide both sides by -1. When I do that, I'm going to get y equals -5/3. So my second ordered pair is going to be 2/3, comma, -5/3. So those are your two solutions.